Okay. Okay, everyone. I think let me. Okay. Now, let's start with the activity. Okay. Every one of you, please go to www.menti.com. Okay. Wait, yeah. Let me give you the instructions. Wait for a while. Okay, let me set up first. Okay. So I hope you can see the screen, yeah? So first, please go to www.menti.com and use the code there. Use the code there. Okay? Or I copy the link. Okay. And then just click in the chat box. Okay? Just click here and then fill up your name. Okay? And please give example of fluid. Okay? All right. Before we start, I want to ask your prior knowledge. Do you know what is fluid? Okay. If you know fluid, please give example. What that the fluid that you know. For example, like water. Okay. Yes. Air, oil, water. Yes. The bigger the words, okay, that will be the more frequent answer. Okay, honey, water, oil, blood. Okay. Air, air batu. Okay. Okay, why air batu? Blood. Okay, ice. Okay, now I'm thirsty. Blood, ocean, syrup. Semua makanan. Blood, oil, milk, tea. Okay, please contribute your idea. I want to see example of fluid like what we call it, like air, like gas, carbon dioxide, consider liquid. Okay. Consider as a fluid. Okay, I want to see your participation. Please give example of fluid that you know. Right? Ah, sabun tekan-tekan. Okay, mercury, nitrogen gas, rain, syrup. Okay, hydrochloric acid. Okay, gasoline or black. Okay. So many creative idea I can see here. Nitrogen gas, blood. Okay. All right. Thank you for your answer. All of you give the correct answer. Okay. But there are something that you must know first. Okay. What is fluid? Some of you give the right answer. Some of you not give the accurate answer. For example, like air batu. Okay. Okay, that is not a fluid. Okay, why? I will explain later on. Okay. Coke. Okay. Santan. Okay, santan. Okay, consider yes. Okay. So now we can see we have so many example of fluid. Thus, okay. All right. Let's go on understanding the fluid. Okay, after you have understand, okay, you give example of fluid, right? Okay. Now we need to know exactly what is fluids. A fluid is a liquid, gas, or other material that continuously deform under apply shear stress or external force. For example, this is solid. I give certain kind of stress or external force. I push this solid. What happened if I push the solid? What happened to the solid? Please volunteer. What happened to the solid after I
Solid
push?
move,
The
deform.
solid deform. Is it continuously deform? Is it continuously? That means you push one thing, you push one time, it will deform continuously. Is it like that, the behavior of fluid? The behavior of solid? No, right? So, what happened to the liquid? You give the external force, okay? Is the liquid will continuously deform? Please answer in your comment here, in the chat. Okay, I want to see. Yes, Ashraf, Eugene. All right. So how about the gas? We give the external force. What happened to the gas? Is it continuously deformed? Of course, it will easily deform. So accept this one. Okay, accept this one. The solid will not deform continuously. Alright. So anything that continuously deform, okay, we call as a fluid. Simple as that. Okay. For example, in this object, we try to replace with the solid. Okay, we have the force. We give the force here. When this is solid, it will not deform. How about this is liquid? Okay, of course, we give the external force, it will deform continuously. Same goes to the gas. So anything that is liquid, gas, or any material that continuously deform under applied stress, okay, stress, we call as a fluid. Yeah, I hope this is simple. You understand? So let's have another intermittent discussion, okay? Please go to the link here. Okay, let me share you the link in the chat box. Okay, wait for a while, yeah. Okay. All right. Okay, everyone, please look at your chat and then enter this link. Okay, now we are going to use the Jamboard activity. Okay. So, please join everyone. Okay, please do not disturb, yeah. Existing one. Okay, please do not disturb the human body, home, energy, and automotive. Also, all this template. Please, I give you about 5 minutes. Please contribute your idea. How does fluid affect our life? So now you already know what is fluid, something that is continuously deformed. How about that kind of fluid affect our human body, affect our home, Okay, affect the energy affected by the automotive. Please use the text here and write your answer. Okay, human body. Please give your idea. I want to see your participations. Okay, please write your idea. Okay. Provide energy. That is good. Okay. If you don't mind, can you give in terms of detail a little bit? All right. Provide energy from which mechanism? Okay. Blood transfer oxygen. Yes, I want like that. That is the blood. The blood is the fluid. And then what will be the function to transfer the oxygen? Okay, I want to see the material. What is fluid? What the fluid do? Okay. Please you can use the sticky note as well and then use the text box. Okay. Please arrange yourself nicely. Arrange the text nicely so that the others can view nicely. Okay, I can see water to shower. Bathroom water. Okay. Um please erase this one, yeah. Right. Watering plant, yes. Water to clean dishes, yes. Okay. Aircon, energy, automotive, oil for combustion, yes. Oil with oxygen, okay, will form the combustion. Lubricating oil for the parts, okay, good. Enable inventions of combustion engine for movement of vehicle as a coolant. Okay, yes, as a coolant is very important. Without the coolant, okay, definitely the car will be burned. Okay, yes, please. Water turbine to provide electricity. That is good. You know how to harness the energy from the water. The air, okay, the air also can be harnessed. Hydraulic dam to generate electric, produce electric with turbine. Can be used as a renewable energy. Yes, good. Okay, human body provide energy, lymph flow in human. Wow, this is scientific. Digest foods. Okay, blood circulation, prevent hydration. Aerodynamic make automotive move faster. Okay, that is good. You have so many good application I can see. Okay, you must be do some revision, I believe. Okay, lots of idea. Airplane, okay. Ocean wave energy, car wash. Not to forget lah, the car wash is also good. Okay, I believe this is enough. Okay, thank you very much for your contributions. Let's proceed now to the next part. All right, now you understand the concept of fluid that affect our life. So that means the fluid is very important and essential to our daily life. Not only our human body, but the home require energy, okay? The energy as well as the automotive. Okay. Okay, after we have known the application of fluids, okay, now let's proceed with the dimension. Okay, now let's proceed on the lecture. Okay, now we proceed on the dimension and units. So, class, what is dimension? What do you know about dimension? Please give your thought in the comment section. Okay, please look at, please give your any thought about the dimension. Okay, Dao Simon. Okay, property to describe the object. Okay, good. Dimensions. Okay. What is dimension? Lim Han said property. Dao Simon. Okay, measurement. Alright. The dimension basically is something that we can measure. What we can measure? For example, our weight. Okay. The table, the chair. Okay, we can measure. So that we call a dimension. So let me give you some of the dimension. The first one is the, who knows? The first one is the, okay. Before we start with the dimension, okay. Something, let me, okay. Something that we can measure. That is a dimension. Of course, every dimension has their own unit. All right. So in the dimension, we have two system of units. All right. We have the English unit and we have the metric unit. Sometimes the English unit we call the imperial system. The metric unit we call SI system. So what are the example of dimension? We start with the length. Okay, so the symbol is capital L. What's the imperial or the British unit? The English unit for the length. Anyone knows? Yes, Nurul Alia, that's good. Length. So what's the unit of imperial, unit of length? Yard. Okay. Okay, inch. So the accurate one is foot. Okay, thank you. Alia, okay, foot. Okay, the unit here FT. Okay, the SI unit, the one that we normally use, okay, in Malaysia is meter. So the symbol is M. So how about the next dimension, which is the mass? The mass we can measure, which is capital M. So what's the imperial of mass? Pound. Are you sure? Pound. Oh, so what's the imperial of mass? The pound is not for the mass. Slug. Yeah, sometimes people confuse. Okay, it is slug. Okay, the unit is also include the pound, second, squared per feet. All right. And then the SI unit for mass, of course, kilogram, not gram, yeah. Kilo must contain kilo. So we call it as a kilogram, right? kg. And another one, dimension that we can measure, the time. Okay, capital T. So the imperial and the SI is the same. Okay, the time will never change. Okay, seconds. It is not a minute or hours here. It is the standard we call. This is what we call a standard. Okay. We must use the standard one, the second. So in the imperial, it is quite long a little bit, SEC. However, for the SI, it is second, S only. Right? Another one, the force, F F-O-R-C-E. Capital F. And this is the pound. Okay. In the imperial unit, we call the pound for the force. Don't confuse the force with the mass. The mass we call the slug. The force for the pound. So the unit is LB. How about the SI unit? Anyone knows what is SI unit? For the force. Newton. Why you confused? Don't need to confuse. It is already Newton.
Newton.
Newton. Because the Newton invent the unit. The name of the Newton. Don't confuse. You already know. Okay, the unit is capital N. And then finally, temperature. We can measure the temperature. Okay, so the symbol is theta. However, for the imperial, we have two units. Alright, we have the normal unit and we have the absolute unit. Okay, now we talk about absolute unit. Okay, absolute unit and normal unit. Okay, for the absolute unit, the imperial for the absolute unit, temperature, what it is? It is Rankine. Okay. R. How about the SI unit for the temperature? The absolute one. Kelvin, correct. Kelvin, of course, it is capital K. How about the normal? The normal of the imperial unit. It is Rankine with Fahrenheit. Correct. Nurul Alia. Very fast ni. Fahrenheit. Fahrenheit. Okay. How about the SI unit? This is normal one. You enter the shop. It is 36.5. That is a normal. We call Celsius. Okay. Celsius is the normal measurement for SI unit. This is ordinary. So during the calculation, you must use the absolute or normal. My question. You must use the absolute or normal for the temperature calculation.
Absolute.
Okay, absolutely. Correct. You must use absolute. Okay, remember. Absolute. You must use absolute. Alright. So what's the difference between the absolute and the normal? Alright, let's take a look. This is the diagram. Okay. When this is considered absolute, okay, that means it is under absolute zero. Alright, absolute zero, that means all the atom will stop moving. Do you know that the atom will vibrate, rotate, and move, right? So when it is considered as the absolute zero, all the atom, the molecule or the substance will stop moving. It is like a dying. It is already die. Okay, not move. Okay, that is why the absolute zero, temperature at which the molecular stop motion. So what's the temperature? It is negative 273.15 degrees Celsius. Okay, this is 0 degrees Celsius. It is ice. Air batu. The ice still, the motion have, the particle will have the motion. Okay, the human body temperature. Okay, this is a boiling of water. All right. So let's take a look about the property of fluid. Okay. Now we try to compare solid versus fluid. Molecule of solid are usually, what do you think of the answer? Usually close. Okay, closer together. Okay, this is, I believe you know, yeah, during what you have studied before. The molecule of solid close together, very packed. Solid tend to retain the shape. Okay, retain its shape. Okay, due to the very large attractive force. Okay. Attractive force in the fluid are not as strong as solid. Okay. Fluid flow under slightest stress and continue to flow as long as stress present. Okay, that is all about the comparison. How about liquid and gas? Fluid can be a, okay, this is very important. Fluid can be a gas. Remember that we have learned earlier, or a liquid. Molecule in a gas are much farther apart than in a liquid. This is true lah. Okay. This is a gas. This is liquid. Okay, the molecule farther apart, but the liquid close, sometimes quite close to each other. Gas will expand if the external pressure are removed. Okay, liquid is relatively incompressible. Okay, liquid won't expand even if all the external pressure are removed. Okay, that is the liquid property. How about the vapor? Vapor, the gas whose temperature and pressure are such that it is very near the liquid phase. Okay, the example of vapor is the steam. Okay, is the steam considered a gas? Anyone? The steam. Okay, Hadi, why? Hadi, Syahir, why no? Okay, vapor is a water. That means the water that is heat up, it will become the vapor. The gas, it is out, it is exclude the water. For example, carbon dioxide, nitrogen dioxide, sulfur dioxide, all those things considered as the gas. Okay, only water become vaporized, we call as a vapor. So volume of gas over vapor is greatly affected by the pressure and temperature. Of course lah, we give the pressure and the temperature, it will be move dynamically. Okay, I believe this semester you already taken, you are taking the thermodynamic, right? Okay, do you take the thermodynamic this semester? Yes. So, please remember this. Fluid and thermodynamic are interrelated. It is need each other. Okay, sometimes the fluid explain the concept of thermodynamic. Sometimes thermodynamic explain the concept of fluid. It is interrelated. Okay, thank you everyone. Okay. After this, we're gonna have the quiz, yeah? Please remember all that we have learned. Okay. Okay. Now let's start with the basic term to be used for the rest of the course. Okay. The density. So what is density? The density symbol is rho. This is rho. Okay, this is rho. So what is density? Density is mass over volume. So what's the unit of density? The mass is kilogram per meter cubic. This is the unit for the density. How about the specific weight? Okay, the symbol is here, gamma. How to write this symbol? This is like this. Okay, the gamma is equal to the weight over width volume. Okay, so another another equation. This is formula number 1. This is formula number 2. Gamma is equal to rho multiplied with the gravity. Okay. Alright, why the rho multiplied with gravity? You can see here. Okay, what is the weight? Weight is the mass. Okay, multiply with, what is the formula of weight? Mass multiply with, anyone knows? Okay, correct, gravity. What is a volume? Is a volume. Okay, the symbol of volume is V. So mass divide with volume. Mass divide with volume. What do you get? Mass divide with volume. What do you get? Density. So that is why density multiply with gravity. You can see here. Okay. I believe you understand, yeah? The specific weight is a rho multiplied with gravity. Alright. So what's the unit? The unit. The unit is weight. Weight is Newton divided with volume, which is meter cubic. Okay, this is the unit. Okay, now we proceed with the specific volume. Okay, this is the symbol nu. So nu here is basically, okay, this is volume. So volume divided with mass. Okay. Or, right, 1 over density. The same thing. When you try to inverse the density, it is volume over mass. So you try to inverse again, you will get the new, which is specific volume. Okay, you can see volume over mass, the same thing with the mass over volume. You try to do the reciprocal or inverse of density, 1 over density, it is the same thing. Okay. So what's the unit? What's the unit? Volume meter cubic per meter cubic per kilogram, right? And finally, specific gravity, SG. Specific gravity is the ratio. Please remember, SG is the ratio. So it is the ratio. Okay, specific gravity, we have two, yeah. Specific gravity of the liquid is equal to the density, is equal to the gamma of liquid over the gamma of water at standard temperature. Or we can expand further, gamma is equal to rho multiplied with gravity. Okay, rho of liquid over rho of water multiplied with gravity. Now we can cancel gravity with gravity. We will get here is the density of liquid over the density of water at standard temperature. Right? Now we proceed to the last one, specific gravity of gas. For example, this is gamma of gas over gamma of air. Okay, air at the standard temperature, standard condition. So gamma is a rho of gas multiplied with the gravity. Rho of air multiplied with gravity. Gravity we can cancel out. So what we left here is density of the gas over density of air. Okay. So what is the density of water? Anyone knows? What is the density of water? Okay, the screen is split here. Okay, it is 1000. Please provide the unit, yeah. It is kilogram per meter cubic. What is the density of air? What is the density of air? It is, at the standard temperature, it is 1.205 kilogram per meter cubic. Alright, so now you have gone through the basic term of fluid mechanics, the specific gravity, the specific volume, specific weight, density. Let's go to the quiz time, okay? For this one, we want to see who is the winner. Please use your full name, yeah? Okay, I want to see who will be the winner. Let me share the screen and then go to menti, menti.com. Let me give the instruction, yeah. Let me give you the number. All right. Okay, let's recap that we have what we have learned. Okay. Okay, please go to wait, yeah. Okay, you can click in the chat box here, www.menti.com. Click and use your full name. If you get the highest score, I will give you the extra bonus point for your coursework. Okay, before we end the session. Okay, please answer the first one. Please name the 2-unit system. Okay. Is it English and imperial unit or English and metric unit, or is it metric and SI unit, or SI and absolute unit? Please give your answer. Who first will get more points? All right, we have 32 vote for English and metric. Please remember, we have 2-unit system. What we have? We have the imperial. We have the imperial unit and we have the SI unit. Remember? We have imperial and SI unit. So what's the final answer? Okay. Let's proceed on the next task. Okay. Okay. Answer fast to get more point. What is the imperial unit for the force? Okay. Please think first. Please think. Okay. 3, 2, 1. Time's up. Please answer fast to get more point. All right. So the answer is pound. Okay. It is not a slug. It's also not the food. Okay. Who is the winner? Let's see the scoreboard. Okay. Barefoot Contessa. The faster one. Okay. Next one. Please answer fast to get more point. Absolute temperature will cause. Okay. Absolute temperature will cause. Okay, please answer. Okay, question 2 of 5. Okay, density is. Okay, 10, 9. Density. What is the density? Okay, some of you still choose mass over weight. The right answer is mass over volume. That is the density. Let's see who. Okay. Okay. Barefoot. Still the faster one, yeah? I don't know who are you? Okay. Okay, please. Specific week is okay. Who got the okay? The specific weight is the weight over volume or the density multiplied with gravity. Okay, now we can see. Move. The cake now. The cake move to the top leader. Ashraf, Nasrul. Okay, good. Specific volume is? Specific volume is? Okay, please, fast. Time's up. Okay, correct. 1 over density, volume over mass. That is correct. Let's see who got the win the leaderboard. Okay. It looks like barefoot want to. Okay, barefoot the faster one. Okay, go to the second leader. Okay, the last one. Who will be the winner will get the bonus mark. Time's up. All right. So 24 correct. So the answer is ratio of specific weight liquid X over specific weight of water. Same goes to the air. Finally, who is the winner? Okay. Ashraf, congratulations. Okay, Ashraf, can you introduce yourself a little bit? And please explain how you score well. Ashraf, who are you? Congratulations.
Hello, doctor.
Okay, congratulations first of all. Okay, please introduce
Thank
yourself
you.
and explain and explain give a please explain to your friend what's your strategy to score high.
Assalamualaikum and hello everyone. My name is Muhammad Ashraf bin Azhar. The strategy is I wrote down the formula that you gave just now, and also a little bit of um, reading before the class
Okay, good.
based on
Okay.
your notes.
Okay, good. Ashraf, can you give your full name and the metric number? I want to add into your score point. Can you give in the comment here, yeah?
All right, thank you.
Okay, thank you. All right. Let me write down your name. Okay. So here is basically the winner is please Muhammad Muhammad Ashraf. Okay, bagus Ashraf ni. Okay. Bin Azhar. Section apa Ashraf? You are section. Section and metric number, please. A20E
Section
M012.
15.
Section 15. Okay, thank you. Right. I think I would like to share with you the course information. I believe I haven't explained right the course information. Okay, this is very important. Okay. The course information. Right. I believe you can see, this is the course information that will explain to you all the course synopsis. You can read on your own. Okay, this is the lecturer name that teach your fluid mechanic. And this is the course information. Okay, the most important thing in the course information is the CLO. All right, this is what you obtain. You will obtain after you finish the course. The first, you will obtain the knowledge, calculate and analyze shear stress in the fluid flow, pressure difference in manometer, hydrostatic forces on plane or curved surface, buoyancy force, stability submerged and floating body. Okay, this CLO, we have 4 CLO mapped to the PO1. Okay, this is program outcome. This is after you graduate from UTM. Okay, in UTM, how many PO do we have? Do you still remember how many POs? What is the total PO at UTM? Have you forgotten during the first briefing of your first year, first semester? How many PO? We have, okay, I will share to you later on. We have 12 PO. Fluid mechanic 1 only cover 1 only PO, which is PO1. Okay. This is the weekly schedule. This PO, this course information has been posted in the e-learning. Please access your e-learning, yeah. Okay, this is the course overview. Okay, remember week 1, I explained to you the course information. And then the introduction of fluid. Remember, we have learned the definition of fluid, dimension and unit, as well as the fluid property. We learned about the density, the specific weight, specific gravity, the gamma, okay, and so on. And next week, we're going to learn the fluid property as well and the fluid static. And this is the rest of the lecture. Okay, for those like like who is the winner before? Ashraf kan? Ashraf. Okay. Read before the class. Okay, you may read before the next class. Okay, you may read the fluid property. After you understand, gain the understanding, you will score better during the quiz, during the class. Okay, how to score in your exam? Okay, we have the coursework and the final work. The coursework represents 60%. From assignment, 10%. Programming assignment, I will give you the MATLAB assignment. The test 1, 20%. Test 2, 20%. And your final is 40%. Okay. So what is the passing mark for the fluid mechanic? Who knows? What is the passing mark? Passing mark for the fluid mechanic? Okay, 50. Why 50? Why not 40? Okay, 40 is for non-core subject. Yes. Fluid mechanic is the core subject. You must score more than 50 to pass the subject. Alright. You are engineer. You are going to become the engineer. So you must, of course, you must master the core subject. Okay. At least get more than 50. Get B, A. It is better for you to become engineer. So this is the reference book I have posted also in the e-learning. You may buy the book for your reference or you may download the ebook from website. Okay, I think that's all for today class. I will share you the attendance again. Okay, do you have any question? Okay, do you have any questions so far? No, for now. Okay, thank you. Thank you, everyone. I think I end my session with Assalamualaikum warahmatullahi wabarakatuh. Have a good day, everyone. Stay safe, yeah?
I want to start first.
Okay.
Thank you, Doctor.
Thank you, Doctor.
Okay. Okay, welcome.
Thank you, Doctor.
Okay, welcome. Yes, Doctor, will you upload the sketch slide? Yes, I will upload later on. Sure. Don't worry.
Doctor.
Okay, thank you. Stay safe, everyone.